Welcome back. Let's continue from where we left off. So in this episode, we're on our second change order for the lubrication system. And one of our goals in creating models within WonderLogix Studio is to make them both flexible and understandable. This helps not only in the current project, but also for reusing components of the system as classes that can be reused in other systems. So let's see what our second change order is. So what they would like us to do is to improve the ability to modify the time and the value limits, which are currently hard-coded. So if you remember from when we did this earlier, we have a time constraint on the pump failures, right? So if they run for 3 seconds, that's hard-coded. And then also here in the level of the tank, we have a value of it had to be greater than 20%. Well, those are hard-coded into the logic. We're being asked here to make this easier to modify, plus we can want that modified for every place it occurs. So how are we going to do that? Well, let's replace those hard-coded values in the oil tank and the pump with parameters. Now, so far we've seen two attributes of the component system. So we have here our components, where the logical, the white ones, and the purple or lavender ones are physical ones. And the interface attributes are those signals that interface to the components. So we have an input interface and an output interface. We also have internal attributes. These are variables and logic that are available to the components inside of the components themselves. And that would be parameters and properties and state machines. And we'll get to properties and state machines in later videos. But for today, we're going to talk about parameters. So a parameter is an item that can hold a value, right? It's a variable with a name. It can hold a value. It is not updated by the model. So later you'll find out that properties can be updated by the model, but parameters are not updated by the model. They can, however, be set to be updated by the HMI. So for example, we might create a parameter that has a set point or a recipe number or something that we want the operator to be able to update live from the HMI. But it is useful to hold a value here with a parameter name so we can actually use the English name within our logic to help improve understanding and make it easier to update all in one place. So let's show you what we're talking about in this case here. So the first thing we want to do is we want to create a named parameter for these time and value limits. So let's start with our pump units. So if we go into one of our pump units here and our backup pump, and on our failure, we have a 3-second timer. So let's start by trying to replace that with a parameter. So we'll go here and click the plus sign next to parameters. We're going to name this delay to failure. And click create. And we recommend you always start your words with a capital letter so that when they're strung together in the PLC code, they tend to remove spaces, and that way you'll be able to still read them. And now we're going to go update our logic. So let's go open the logic for the failure of the backup pump. We'll click our pencil icon to edit it. And now instead of saying we want the backup unit to receive operate for a consecutive time of 3 seconds, let's replace this 3 seconds with our parameter. So we're going to click this up arrow here, and that gives us a choice of places to find other values. Well, the only place we can find a value here is really in the parameter. And the parameter, as you can see, that's a child of the backup pump unit, right? So it belongs to the backup pump unit. So the parameter of the backup pump unit allows us to see delay to failure. If there were more parameters, we'd have choices here as to what they were. In this case, the only one we have is delay to failure, so it fills that in for us. And whatever delay to failure is set to, we do want to specify that in seconds, so we'll still keep all the rest of this. And now that's set for there. Now, we need to actually set a time for this. To set a time, you'll see it defaulted to 0. We're going to double-click the delay to failure to open our details pane. And it recognized that we were trying to use it as an analog type, so it set the type for us. There are other types we can talk about in later videos. And for an initial time, we're going to go back to what we started with, which was 3 seconds. And then if you wanted them to be able to update this from the HMI, you would check this HMI write box, and that would expose this variable to your HMI system so that you could then access it through the HMI. And we'll click save, and there we go. So now we hold our cursor over the failure. The pop-up tells us that it still refers to the delay to failure for that number of seconds, and in this case you can see it highlights the delay to failure parameter, and it's currently set for 3, and so that's taken care of. And that's a good stopping point. We'll see you in the next video.